box and whisker plot, you start with the median 34.5. So you just kind of say, okay, that's 34.5. And then you roughly figure out where Q1 and Q3 go. So Q1 is 23 away and 44 is like 10 away. So you want to be, roughly proportional. If that's, I should label these. Sorry about that. 34.5 and 44. Then the 23 is going to be about double away from that. You want it to have some sort of sorry, that's 11, where my mind is. Okay. Then the whisker parts. So supposedly these look like whiskers. I don't know. You can make up your own mind. It's the min and the max. Unless you have outliers, then you have to do something different, which you don't have in this problem. Your min is 1, your max is 82. So it kind of should also be kind of to scale here. So if that's another 10, 82 is way over here, roughly. There should be some reasonableness to your work here.
Yeah.
Is that okay?
Yeah.
Awesome. All right. So on to the next question here. This one's got a calculator next to it, but we might be able to do it by hand. In fact, I mean, we should be able to do it by hand. What do you think was the intent of having the calculator button next to the system of equations? Snip it in here. Like, can we just do it by hand? Do you want to skip it? What do you think?
Yeah, we can. I mean, we can do it, right? Yeah.
You can do this without a calculator. This one's not an issue.
Yeah.
It's just this is the way it is. All right. So see how it's already solved for y here? I'm going to put that in for y. So that's x plus 4x minus 7 equals -2, like that.
Yeah.
And then you're going to solve for x. You're going to add 7 to both sides. X plus 4x becomes 5x, 5x equals 5. And look at that. It works out really nicely. X ends up equaling 1. Now you can use either equation, but why not use the one that's already solved for y? Y is equal to 4x minus 7. Why don't we put x in that one? Y equals -3.
Yeah.
That's it. Yeah. Why they have the calculator icon there, I don't know. All right, on to 13. And you have this every day. You got to do this kind of assignment every single day, right?
Yeah.
Man.
Yeah, actually, today was our last written practice, but I still have some missings that I have to do, so not today.
All right. Well, I guess there's an end to everything. All right, balls are printed in a pattern. Every 18th ball has stripes, every 15th ball has polka dots, and every 30th ball has stars. How many balls must be printed to get the first ball with stripes, polka dots, and stars? Okay, it's a really complicated way of asking for the least common multiple between 18, 15, and 30. Okay. Now I think last time we talked about doing a factor ladder to do this. Because 15 goes into 30, you kind of can do it another way, which is to kind of group those two together and say it's really 30 because eventually it's going to work to go into 30. So you just start counting up from 30, 30, 60, 90, and you can actually get there pretty quickly with this. The factor ladder approach is probably what your teacher is looking for. You start with 2 and you go from there. So it's like 3 goes into 9 3 times. Then you do the same thing with 15. 2 doesn't work, but 3 does. 3, 5, 5 and 1. 30, you start with 2, smallest prime number, that's 15. Since 2 does not go into 15, you move to 3, 5, and then 5 and 1. So you start with the smallest number, 3 and 5 in this case. You just write them. It's okay. It's going to be 3 times 5. Then you go to your next smallest number and you say, what do I not have? It's like, well, do I have a 2? Nope, don't have a 2. So I'm going to add a 2. I have a 3, check, but do I have a second 3? Nope, nope. So you're going to add a second 3. Then you go to the 30 and you ask yourself, do you have a 2? Yeah, I got a 2. Do you have a 3? Yep. Do you have a 5? Got a 5. So this is your least common multiple.
Mhm.
Basically pull out those factors and group them here. This ends up being 90.
Yeah. Okay.
Okay, so I think B is actually a more interesting question. It says, how many balls have been printed at the point that only 2 of them, sorry, the snip isn't working.
Oh,
There it is. How many balls have been printed at the point that only 2 of them have designs? Now, they don't say which 2, so it could be so it's like you almost have to like look at like 18 and 15, 15 and 30, you know, which like where's the first overlap? So
Oh,
it's like if you're like, okay, let's look at 18, 15, and then 15 and 30, and then 18 and 30, where would the first overlap occur? And because the niceness of the numbers, this is going to be the first one
mhm.
at 30, because at 30, you're going to get 2 of the designs on there.
Okay, yeah. That makes sense.
All right, so that takes care of that one. Let's go to 14. All right, sorry, snips aren't great. That's okay. All right, Jason is building square deck around his home.
His home is also in the shape of a square.
Yeah, and actually, very few homes are in the shape of a square.
Yeah.
Which, that's okay. So here's his home. Here's the deck. It's good to draw a picture. He
Mhm.
wants the deck to be 9 feet wide around the outer edge of the house. The house has a total side length of 8x. Okay, so this is 8x. This is 8x. And the outer edge is 9. So like this is 9 and this is 9.
Uh-huh.
So the total like height or length is the 8x plus 9 because it occurs in 2 places. And then similarly along the base there, it's the 8x plus the 9 plus the 9.
Uh-huh.
Because it also is in 2 places there. So sometimes it's good to like redraw it after you kind of get everything kind of there. It's 8x and 8x. And then this is 8x plus 18. And then 8x plus 18. Okay, and then we'll see what it's asking for. So it says, find the total, write a special product and simplify to find the area of the house, including the deck. So they want the whole, they want the outer one. You agree?
Yeah.
Okay. So the outer one is 8x plus 18 times 8x plus 18. This is a FOIL problem.
Uh-huh.
You want to attempt to FOIL that for us, please?
Yeah. 18, okay. Oh, sorry. 64x squared plus x. $124x plus 124. Yeah, 24. Okay, so 64x squared plus 124x plus 124 plus 324. Then
Okay.
add
So what's that inner one? What does that inner one become?
the inner one.
Well, they combine. Those middle two ones are going to combine
Yeah.
together. They both have an X.
Like the 124 plus 300.
Yeah, and I think you got it. You said it's because it's 18 times 8. That's 144, isn't it?
Oh yeah.
And then kind of the last piece here is to put feet squared, even though you don't know the actual feet.
Yeah.
All right. Freeform snip.
324 squared. The special product. Oh no, I'm looking at the wrong one.
We can talk about what a special product is, but I don't think it's worth doing right now.
All right. And we're good.
Yeah, I haven't asked you in a while. How's your grade in the class? Have things improved? Are you seeing any light at the end of the tunnel?
Yeah, because I did pretty good on the test, and then I turned a bunch of them in. So
Great. Great. Is that what we've been doing lately? Is just getting you caught up on assignments?
yeah.
Awesome. Awesome. And you said you've got a couple more, or is this it?
I've got a like. 'Cause we had the last one this week. I think I have like the one we're doing right now was one I got assigned on Monday. And today we're doing the last one.
Okay.
Other than that, I have 3 more.
Great. Great. And I'm sure you got a final or something coming
Yeah,
up here as well.
that's what's gonna be.
All right. Great. Okay. So there's a golden rectangle. All right. So here's your golden rectangle. The length of a golden rectangle is equal to x plus x squared 5. And they're telling you the value of x is the square root of 5. They're saying x is the square root of 5. So you're going to take that number and put it in for x. So it's the square root of 5 plus the square root of 5 times the square root of 5.
Oh, okay.
It's a little weird, a little wonky, but it's telling you what to do. It's telling you to substitute.
Yeah. So when you're adding radicals or whatever you call it.
Well, you can't add, you have to multiply first. They think of order of operations, multiply before adding. So multiplying here is the square root of 25. All right, so that this one cannot be combined. It's just 5 plus the square root of 5.
Yeah. But when you have the same,
like here, I think this is what you're asking me. 2 square root of 3 plus 8 square root of 3.
you can just add 2
You
plus 8,
can,
right?
yeah, very good. I know it's sometimes trying to figure out what it is you're wanting.
Yeah,
but,
sorry.
No, me too. I'm not in my best frame of mind here. I'm doing my best to help you today, though. 16.
Yeah.
Here we go. All right, stem and leaf plot, yay.
Mhm.
Are the data in order? No, they are not. My goodness, okay. All righty. It would be really useful to have the data in order. Not necessary, but pretty useful for us. It's kind of up to you if you want us to spend the time doing that. We can start just creating the stems and the leaves here. But we kind of need to decide in advance like what the stem is going to be. So you really need to at least identify the min and the max.
Yeah.
So the min here, maybe 80, maybe. I see another 80.
I think it is.
I don't see anything with a 7 in front. And then the max, 4148.
148. Yeah, I think so.
Okay, so that's a minimum. You ought to at least do that. So now 8 stands for 80, 9, 10, 11. And just because I'm running out of space here, actually I can scroll down a tiny bit. That's still the data. 12, 13, 14. Okay. The reason you want them in order is because you really want to put the leaf part in order, but we can do it out of order and then you can redo it later. So like what I mean by that is it can be 0 for 80, 6 for 86. And then like when we get to the next number with an 8 in front, like the 3, you can either try to squeeze it in there or you can just put it out of order for now and then come back and reorder it.
Yeah.
If you don't like that, then you kind of got to do it off to the side for time being.
Yeah, we're good.
Okay, so I like to do these in order. So let me do that here. So we got, sorry, I'm just gonna just get this thing framed properly. Hopefully you can see all that.
Yeah.
All right, we're up to 105. So that's a 5, a 9, 27, 48, 37. You just start going through the list here.
Yeah.
35, 46, 90, 95, 101, 83, 114, 48, 27, 91, 36, 82, 48, 27, 49. There was a bigger number, I just now noticed it.
Oh,
80 and 86. Yeah, I make lots of mistakes. If that helps to make you feel better when you make mistakes, I make a ton of them every day helping students. But the next thing would be to reorder this. I'll let you do that if you want.
mhm.
The next thing to do here is to analyze the distribution of the data. So I want to do something here. Hopefully I can do it in the space we've got. So I need to grab a snip here of this. And let me see if I can do it. Blessed, come on. All right, so here, grab a snip of that. And I can't remember is if I can rotate it in here. Let's see if it'll let me rotate it. It does not, so I'll do that in another program. All right, and then let me rotate. Okay, so what I've done in another program here is just rotated this image, and I'm gonna snip it back in,
Mhm.
hopefully. And this is kind of like looking at a histogram. You
Yeah.
can think of these as being like the rectangles.
Yeah.
And it doesn't matter if the numbers are in order or not. The distribution here appears to be some sort of like U-shaped thing, which is not a well-known described distribution.
So
So how do we answer this? you would say that the peaks are at the min and the max. If there were more data points, it would be called what's called bimodal. And that might be what your teacher is looking for here. I wouldn't classify it as bimodal without seeing a little bit more of the distribution, the tails here, but we don't have access to those. And if you have no idea what I'm talking about,
Yeah.
that's okay.
I don't think he's looking for bimodal.
All right. I like it.
Okay,
What conclusions can be drawn from this? Let's go back to what it actually is. It's number of customers served each day for dinner, or served at a diner. So it seems like they're either serving very few or they're serving a lot. I don't know, like
Yeah. There's
that would
not.
be, yeah, there's not what you'd like actually is more steady. If you ever work in the food industry, there's these rushes, people want lunch every day from 12 to 1 or 11:30 to 1:30, and then people don't eat until 5:30 to 7:30. That's the window.
Yeah.
All right. Okay, moving on to another question here.
17.
Yeah.
Mm-hmm.
All right, solve the following system using the elimination method. You have to decide which variable you're going to eliminate and why. Can you tell me which variable you might eliminate and why in this problem?
X and Y.
You're deciding between them, like you're looking at the coefficients here, like -8 and 4, and you're deciding like, can I make -8 into 4 or 4 into -8? And then similarly, can you make a 3 into a -5 or a -5 into a 3?
Oh. You can make 4 into -8.
That's right. And that helps you to decide which variable you're going to eliminate. You're going to eliminate X. And usually don't think about it in terms of like which variable, you just think about it in terms of what I multiply the equation by. But you're choosing, because they're opposite in sign and because 4 goes into 8, to multiply by 8 or by 2. So 8x plus 6y equals 56. It's a really good idea to rewrite the equations.
Yeah.
Rather than have all the extra letters and possibility of.
Six. And then we can eliminate 8x.
Yes. So you add them up vertically.
So -11y.
No, you're adding. So the second one, do your equations match mine? The first one's exactly the same. The second one, you're multiplying everything by 2.
Oh, it's because. No, yeah, it's just I had subtraction for. I had like -6y, but. Okay, so just -y then.
A positive y, -5y plus 6y. You owe someone $5, you have $6, you now have $1.
And y equals 3.
4.
Oh, I was okay. Sorry.
It's really easy to look at the wrong equation. I'd almost show you this one boxed in without focusing on other stuff.
All right. We can do 18.
Yes, but we're not done with 4. This one we got to go back and find it. Yeah, you got to find X. So you choose the equation you like better. I like the second equation better because there's no negatives in it, and you substitute that y value in. Okay, and we don't have any way to know if it's going to work out nicely, but you just carry through the calculations, and hope for the best. All right, so let's go to 18 next, if you will.
Yeah.
All right, so the relationship between the intensity of sound is given by this equation down here. It says I equals K over D squared. And if you sit only 1 meter away from the stage, the raw constant intensity of a sound is about 0.1 watts per meter squared. So what they're trying to do there is give you enough information. They're telling you the distance. They're telling you the distance is 1, and they're telling you the intensity is 0.1. So if you recall earlier, we did an inverse variation problem that kind of looked like this. It was K over X.
Mhm.
So we're going to do the same thing here. We're going to first use these two pieces of information to find K. So the intensity is 0.1, K is unknown, but D is 1 squared. So what is the value of K in this equation?
Sorry, let me look at it one more time. So that's 1 meter away from the sound is. So the distance squared divided by, so is K1?
Yes. Yes. So that makes our equation real nice. It's doesn't have a lot going on. It's 1 over the distance squared. All right. Now, in this, now we can do the rest of the problem, which is it's in the last like 2 sentences or last sentence there. The whole part where it says if Vanessa, let me snip this in. It says if Vanessa does not want the sound intensity to be any more than 0.0001 watts per meter squared, how close to the stage can she sit? That's the intensity. They're giving you the intensity, 0.0001, and they're asking you to solve for D. Okay, this is a little bit more involved, so we'll do it together, but it's a lot like the inverse variation problems where you find the constant and then you work on X and Y, or you get an X to find a Y or a Y to find an X. So to solve this for D squared, you're going to multiply both sides by D squared. So this becomes D squared 0.0001 equals 1. And then you're going to divide both sides by 0.0001. Okay. And this is where I'll remind you to eliminate the decimal inside a fraction. You multiply by a number, basically however many decimal places you have, 1, 2, 3, 4, 10,000, like that. So your D squared is equal to 10,000.
Yeah.
Which doesn't seem right because you cannot take the square root of 10,000 evenly. Just look here.
Yeah. Well,
like if it were 100,000, it would be fine, or 1,000. No, wait, I'm wrong. I am wrong. This does work. It's the square root of 10,000, which is 100 meters away. 10 to the 4th, cut it in half. Okay. So the way this works is it's 10 to the 4th is 10,000 the square root part is
Uh-huh.
the 1/2 power. And so you multiply the exponents to get 10 squared, which is 100.
Oh. So. 100 is how close you can.
Yes, 100 meters away from the speakers. I mean, if you've ever been to a concert, dance, if you're close to the speakers, you get a lot of sound. But if you move further away, it's not so bad.
Mhm. All right.
That was a tough one.
Yeah.
All right, so 19's kind of long. Just gonna throw that out there. I'm happy to do it.
A, B, C, D, rectangle.
Is it just 20 questions or is there more? Is this it, the last two?
These are the last two.
Okay, then we have plenty of time. I didn't know if there was like up to 30 or something. All right, so to prove something is a rectangle, and this is not like a full proof, but here are the things that you need. You need to prove that opposite sides are parallel. Okay, so that refers to the slope.
Mhm.
So basically, you need to just prove that the slope. I'm gonna
Is
do
it-
it this way. Go ahead.
Yeah, just that the slope is the same.
Yes.
Mhm.
And then M AB is equal to the slope of DC. So that's the first thing we're going to do. Let's just do that now, and then we'll talk about the second thing. This is not enough. This is what's called a necessary but not a sufficient condition. It means that it's needed, but it doesn't guarantee that it is.
Mhm.
I'll probably leave you to do that. I would recommend using the counting method. I would literally sit there and be like, okay, from A to D, how many down, how many right? From B to C, how many down, how many right? So I'll let you do that for us, please. Give me the slope whenever you've got it from A to D, B to C.
1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So like 4/6, like the rise or the run.
But it's down 4 and right 6. And we should simplify that. What would that become?
Oh, it would stay as a negative, right?
Yes,
So just 2/3.
negative 2/3. Okay, so do the same thing for A to B. You can use rise over run, rise over run. You got to make sure that they are in fact the same.
1, 2. What is it? 3/2.
Yes. Okay, fantastic. So now we need the second condition. Yeah, snip that in here. So the second condition is that the distance from A to D equals the distance from B to C, and then the distance from A to B equals the distance from D to C. So you have to use the distance formula or the triangle stuff here. So when I say triangle stuff, it's the Pythagorean theorem. Like from A to D, you kind of already have done this. It's the fact that, do you see that this is a triangle here, a right triangle?
Uh-huh.
You're just trying to find the hypotenuse. You went down 4, right 6. So you're finding the distance or the length of the hypotenuse using the Pythagorean theorem.
Mhm.
That's one way. You can also use the distance formula. Which do you prefer?
We could just do the Pythagorean theorem.
Okay, good choice. I like it a lot. So it's 4 squared plus 6 squared equals D squared. Now what's nice is you don't have to actually simplify it. You can leave it as distance is the square root of 4 squared, which is 16
Oh.
plus. you can just say, oh yeah, it's the square root of 52, whatever that is. You don't have to actually calculate it.
Mhm.
But you have to show that the other one,
Is also.
yeah, it's 4 and 6. Notice it doesn't matter which way you're going because it's a triangle.
Yeah.
You know, if you want, you can sort of show it this way, but they are identical. And then similarly, you would do the same thing for the distance from A to B and D to C.
I have a quick question.
Of course, yeah.
So when we proved that the slopes were the same, like from A to B, it was.
3 halves, same from D to C.
Oh, okay. So like we're proving that the ones that are parallel have the same slope.
Yes. And
Okay.
the second one is that opposite sides are congruent. I didn't write it down, but it's number 2 is that opposite sides are congruent.
Uh-huh.
Okay, so that's what we're doing here. So from D to C, it's the same thing. It's another triangle. It's 3 squared plus 2 squared equals D squared.
Uh-huh.
And then you can, yeah, I don't know, you can maybe switch the order, maybe do that because then it kind of shows that it's different, but
Yeah. I think that proves it.
okay. All right, so that's something you'll see in geometry. I guess you're taking algebra next year, but you actually know most of the algebra you're going to see next year.
Yeah.
But all right, which one of the following systems has only one common solution? So there's actually 4 problems here. And you almost have to do them all unless you're a really good guesser, I guess. One common solution, what that means is that the lines intersect in one place.
Yeah.
And how do you want to proceed? You just want to go in order, A, B, C?
I mean, yeah, sure.
Okay. So first one is setting the equations equal to each other because they're both solved for y. So that's minus 7x equals 21x plus 6. To solve for y, you can subtract 21x from both sides. Minus 28x equals 6. And then you can divide both sides by minus 28. Gets worse before it gets better here. You divide both of them by 2, looks like.
Mhm.
So it's negative 3/14. And then to find y here, you use the fact that it's minus 7x. So x is minus 3/14. This becomes 21 over 14.
Uh-huh. So
Which is 3/2. So if you get an ordered pair, which is the case here, you do get a single solution.
right.
So we almost want to go through the other ones just to like know why they're not one common solution, but if you're satisfied with this, we can call this question good. Or if you want more explanation, we can do that as well.
Well, I kind of get it. Like if they're the same line, then they have infinite solutions. And if they're parallel, then they have no solutions. Right?
Exactly. Yep, exactly. So if they intersect, that's the only way they're going to have one common solution or one x and y.
Yeah. Okay, so I'll send you one more thing real quick.
Sure. Sounds good. We got some time left.
So I'm just gonna attach it back into the email.
All right, yeah, let me know when it goes through. I'll take a look.
Right, there you go. Whatever we can get done.
Got it.
I think I sent it to you.
Let's see here.
Did I?
Yeah, uh, yeah, see, I don't know if it went, if there's any attachment here. Let me, it doesn't look like anything got attached, unfortunately.
Oh. Let me try one more time. But I think I did that correctly.
There it is. Yes. Okay. All right. So let's see here. I've got 11, 12, 13, 14, 15, so on. Where do you want us to start?
Oh, I cut off some problems. Do you mind if I just like tell you, because I cut off like 3 problems. Do you mind if I just tell you the equation?
We can try. We'll see if it works. Sometimes it's not always efficient. Go ahead.
So number 8 is x is equal to 2/3, or because it's writing an inverse variation relating x and y.
Okay.
Then the other one is y equals 33.
8 over 33.
No, just y equals 33.
Okay. And then you said inverse or direct.
Write an inverse variation equation relating x
Okay.
and y.
All right. So inverse variation is k over x, like this. You have to know the inverse one.
Yeah.
You have to have that really well down. Y is 33. K is unknown, but x is 2/3. You have a couple of choices when you see this in the bottom here, like this. You can manipulate the fraction, or because you're trying to clear it, you can multiply both sides by what's on the bottom. So even though what's on the bottom is a fraction, you can still multiply both sides by that fraction. Does that make sense?
Yeah.
If you don't like it, I mean, that's way one. I heard a little hesitation there. I mean, way number two is to literally figure out what does it mean when you have a fraction at the bottom? You're multiplying the top and bottom by the reciprocal.
Uh-huh.
Okay, so that becomes in the top 3 over 2k over 1, which is just 3 over 2 times k. And then what do you end up multiplying both sides by anyway?
2/3.
2/3 again. So it's like, do you want to do it from the beginning? Do you want to manipulate it and then do it? Both are okay. You got to decide. Like sometimes you got to do a few and then you're like, all right, why am I doing that? It's the same thing over and over and over
Yeah.
again. Kind of your call. What is 2/3 of 33?
Well, if I multiply them like 66/3, I guess, but that's
It's better to divide first. Take 33, divide it by 3, and then multiply the result by 2.
so 11, and then 20, and then multiply with, so 22.
Yes, yes. And that's the value that goes back into this equation here. So it's y equals 22 over x. Yeah, 22 over x. Is that all it asks for? Does it give you an X and a Y to find,
No, it just tells you to write an inverse variation equation. So,
okay. All right, is 9 something you can give verbally or
Yeah,
not?
it's just the same thing. It's X equals 6 and Y equals 14.
And it's inverse variation or direct?
Yeah, it's inverse.
All right, so Y equals K over X. Why don't you try solving this one for K for us, please?
Mhm. 6 times 6 times 6. So I did 14 equals K over 6. Multiplied both sides by 6.
Good,
We got 84 equals K.
good. So that's going to go back into the original equation.
Uh-huh. Equal 84, right? Yeah, okay. All right. Then 10 we can skip.
Okay.
And then
So I do have 11 up here, so I can snip that in.
yeah.
All right, so here we go. When one set of data values increases as the other set of data values decreases, what type of correlation does that represent? So there are two scenarios here. One is when the data goes up and to the right, okay? And this is when, and I'll just use variable X increases, Y also increases. But it also means that if X decreases, Y also decreases. So they go take positive correlation, which is what this one means. They're going in the same direction. Okay. Now the problem that you're asking about is the other direction. So I'm giving you both pieces of information so you can do the other one.
Uh-huh.
This one says that as X increases, Y decreases. Basically think of a point way out here. X is big, but Y is small. And then up here at the top, X is small, but Y is big. So
Uh-huh.
these go, this is negative correlation, and it's because the variables go in opposite directions.
Uh-huh.
And that's what is implied here.
Yeah, this is scatter plot. That's right.
Yeah, we're not gonna be able to have time for that. I'm just gonna see if there's anything we can do really quick here.
Yeah.
Probably, so 12, or I'm sorry, 13 is based on whether the data goes up or down. So it basically refers back to what we did in the previous problem. So when you graph the data, you're looking for something that looks like this or looks like this on the right to make that decision. We can kind of look at the data values to see that. So let me just snip those in. So you can, basically you're looking like, do the values seem to get bigger or get smaller as you increase? 68, forget about that value. 75, 96 are getting bigger, but then they get smaller. They
Yeah.
look like they generally increase. So you're probably going to see positive correlation. All right, we do have to stop here for today. Let me go ahead and stop the recording.